SN2 reactions. Primary alkyl halides undergo SN2 reactions. This is primary alkyl halide because carbon is attached to no other carbon. Carbon is primary carbon when it is attached to no other carbon or only one carbon, that is primary carbon. Here carbon is attached to no other carbon. So this is primary alkyl halide. We can explain this SN2 reaction by using primary alkyl halide. But I am replacing this hydrogen with X and Y and Z. Why? Because when we take all hydrogens, all groups are hydrogens, then this carbon is not a asymmetric carbon. Carbon is not a symmetric carbon. When carbon is not a symmetric carbon, we cannot have optical isomer RRS. I will show how this one configuration changes to other configuration. R changes to S or S changes to R. So for that I have to take a asymmetric carbon. Asymmetric carbon is a carbon which is attached to 4 different groups. Now this carbon is attached to 4 different groups. And these groups are small groups. Assume these groups are small groups. Not like in tertiary alkyl halide. Okay. So less steric hindrance. Remember, in tertiary alkyl halide, more steric hindrance. But in these X, Y, Z are small groups like hydrogen. Assume like that. Now this is treated with KOH, and this ionizes into K plus and OH minus. Now OH minus can attack from front side which bromine is attached. So this is front side, and also can attack opposite to the bromine side. So this is back side attack. But through this direction, OH cannot enter through this direction because already bromine is present. So bromine repulses this OH minus. So this attack not possible. So OH minus can attack from back side. When OH minus attacks from back side, we get a transition state with coordination number 5 with 5 bonds. Here 5 bonds are there, and I have shown these bonds as dotted line. Why? Because these are partial bonds, these are not complete bonds. As this OH minus attacks and forms new bond, this bond gradually disappears. So this is a decomposing bond here, decomposing bond, and this is newly forming bond. So this state gradually changes to new state, transition state, and also continuously changes to another complete product, and whole this conversion takes place in single step. So this is concerted mechanism. This mechanism is concerted, takes place in single step. This is a transition state. This is not an intermediate, this is transition state. Gradually changes from here to product. Sorry, here this one is Y. If this molecule is R configurated molecule, this molecule will be S. If this molecule is S configurated molecule, this molecule will be R. But note, when priority of this bromine is highest in this molecule, this OH priority should also in first place. then only this configuration changes. R changes to S, S changes to R. Configuration changes. So this gradually and in single step changed from reactant to product. I will show you molecule models. This is Z and this one is X and this one is Y, and this is the leaving group bromine, and this blue one is carbon. If this OH minus attacks from back side, because it can't attack in this way in front side because this bromine repulses the OH minus, I will show you this OH minus. This is OH minus. This OH minus now attacks from this back side. When it forms new bond with this carbon, this bond gradually decomposes and we get one transition state. When this OH minus approaches this carbon, this OH minus pushes these three groups slightly away from this OH minus, pushes slightly away, so that we will have a transition state. I will show a transition state here. It forms a transition state. Now this bromine decomposes completely left, and this pushes, and again 109 degrees as in sp3 hybridization again restores. So we will get a product, this one. Finally we get a product, this one. Here what happened, this X, Y, Z are flipped from this direction to that direction. It is like a flipping of umbrella in strong wind. So inversion taken place, configuration changed.